parallel and perpendicular lines. What we should know by now is that parallel lines are lines that will never meet. So examples of those are railway lines, the lines in trapeziums or parallelograms. And graphically speaking though, parallel lines have the same gradient, so they're the same slope. The gradients of perpendicular lines, so they would cross each other at 90 degrees. The gradients of them multiply to -1. Or another way to think about it is the negative reciprocal. So parallel lines, first of all, they never intersect, so they never meet. They have the same steepness, the same gradient, but they have a different intercept value. So we can see that these two lines are parallel. They remain the same distance apart throughout the length of the line. And they have the same steepness and everything. If we look at the equations, the equation of this one is y equals 2x plus 5. And this equation is 2x minus 3. So the two x's are the same. The only thing that's different is the intercept. If we were asked to give the equation of any parallel line, you'd first of all have to work out the gradient and the intercept. We keep the gradient the same, but then we change the intercept value. So if we wanted to write any other equation of a line that was parallel to 2x plus 5, we could have y equals 2x plus 4, y equals 2x plus 3, y equals 2x plus 1. We could have y equals 2x, because in that it would be 2x plus 0, but we don't really need the plus 0, so we could have 2x. And there would be an infinite set of lines that would be parallel to both 2x plus 5 and 2x minus 3. So perpendicular lines then intersect or meet at one coordinate. So we can see that they're meeting at this point. And they're perpendicular, which means they're at right angles to each other. So this was the line we had previously, 2x plus 5. And this is perpendicular and it's minus a half x plus 41. So what we can see is that if we look at the gradients, we have 2 and minus a half, and we can multiply those together and they equal -1, and that's always the case. So if we had a gradient of 3, if we multiplied it by minus a third, again that equals -1. And the way I was able to get that so easily was one of the other ways we look at it is the negative reciprocal. So the reciprocal of a number, so if I had 4, the reciprocal is 1 over 4. If I had 3/4, the reciprocal would be 4 over 3. So it turns a number upside down. And then it's the negative reciprocal, so if it was 4, it would go to minus a quarter. If it was minus 3/4, the negative reciprocal would turn it positive, so it would remain as positive 4/3. Another way to do it is just simply by dividing the original gradient into -1. So let's look at this example. So write an equation of a line parallel to and perpendicular to these lines. So let's look at part A. The gradient is 3, and a parallel gradient is also going to be 3. So the parallel line will have the form of y equals 3x plus anything. So plus 1, plus 2, plus 3, plus anything other than 5. And remember, we could have had y equals 3x also, and that would have been fine. Now we need to work out a perpendicular gradient. And to work that out, it's the negative reciprocal. So the reciprocal turns it upside down. So that's going to change 3 into a third. And because our gradient originally was positive, that means the gradient of the perpendicular is going to be negative. So that means we've got any line of the form y equals minus a third x plus anything. We're not restricted to any number because we weren't given one to begin with. So let's say minus a third x plus 7. Okay. Part B, we've got 2x plus 5y equals 7. Now, this is a little bit more awkward because it's not in the form y equals mx plus c. So we need to try and manipulate it to that form of y equals mx plus c. So to do that, we're going to get rid of the 2x first of all, and take it over to the other side. And we'll have 5y equals minus 2x plus 7. And then if we divide by 5, we get y equals minus 2 over 5x plus 7 over 5. So divide everything by 5 there. So here the gradient is equal to minus 2 over 5. So a parallel line is going to be the form y equals minus 2/5 of x plus any number other than 7 over 5. So let's this time do minus 5 because of course it can be a negative number as well. The perpendicular line, so we need to work out the perpendicular gradient first of all, and that's going to be the negative reciprocal of minus 2 over 5. So if we turn the fraction upside down, we're going to get 5 over 2, and because the gradient was negative, the negative of a negative is a positive, so it's going to be 5 over 2. So the equation of the perpendicular is going to be y equals 5 over 2x plus anything, so let's say plus 3. Part C, a parallel and perpendicular line to y equals 5. Now before I think about that, I want to try and draw the line of y equals 5. So I've got my axes, my x and y. Y equals 5, so that was one of those funny lines, and what we have is the y coordinates are always 5. So the line will go through 0, 5, go through 1, 5, and 2, 5, and 3, 5, and 4, 5. So yes, that's right, it was a horizontal line passing through the y-axis at 5. So now what we have is in finding a parallel line, it could be any line of the form y equals. So it could be y equals 4, y equals 3, y equals 2, anything we could have there, anything we want there. The perpendicular line, well, if I was to draw a perpendicular to line y equals 5, that could be it there. Now that's going to pass, I'm going to say, through 3. And let's think about the coordinates there. So that's 3, 0, 3, 1, 3, 4, 3, 5, 3, 10. All the x values are 3. So a perpendicular line could be something along the lines of x equals 3, 10, 170, or whatever it might be.